this is Dr. Leila Farivar for Econ 4400. In this video, I'd like to show you how to find the rejection region for a hypothesis test using the t-distribution table. At this point, you should have already estimated your linear regression model, a model, for example, like this, with only one independent variable, and you also needed to set up your hypothesis. There are three ways that you can write a hypothesis about one of the population parameters in this regression model, and let's say we are interested in beta 1. So there could be three types of hypotheses we can write about beta 1. The first type is called the one-sided or one-tail test, hypothesis test, and the other one is a two-sided or two-tail test. A one-tail test could be left-sided or right-sided. So if I write this H null about beta 1, against the alternative that beta 1 is larger than 0, this one is a right tail or right-sided test. I can have a left tail test as well. Where my alternative hypothesis only has values to the left side of the hypothesized value. In this example, it's 0. So this is a left tail test. And we can as well have a hypothesis that attributes values to our parameters that are at the both sides of the hypothesized value. The alternative would be something like this, beta 1 being not equal to 0 versus the H null that beta 1 is equal to 0. And that's a two-tail hypothesis. So before we go into finding the rejection region, we should know which type of hypothesis we are dealing with. Is it a right tail test? Is it a left tail test? And is it a two-tail test? Get rid of this window. Alright. Let's start with a right tail test. So let me rewrite the hypothesis here. Beta smaller equal to 0 versus the alternative that beta 1 is larger than 0. This beta 1 having values to the right of 0, the hypothesized value, makes this test a right tail test. For a right tail test, the rejection region is in the right tail. So rejection region in the right tail. So looking at the picture, if the shaded area is equal to alpha, the significance level of the test, let's for now assume that alpha is equal to 5%. Then if I find the borderline of this area, this shaded area, the point here, anything to the right of this point will constitute my rejection region. So rejection region would be any value of t that is larger than this border point here. Now, finding this border to find this border point, we need to refer to the t-table. So let's quickly look at the other two types of the hypothesis testing. Let's say now we are looking at a left tail test. So setting up our alternative, Now alternative should have value only to the left of the hypothesized value of 0. Now the rejection region would be in the left tail. The picture here is showing the shaded area, which is not corresponding to our example here, but let me consider this. So if this red shaded area is equal to alpha, the significance level of our test, let's keep our assumption that our significance level, which is the probability of type 1 error, is 5%. Then the rejection region would be anything to the left of this point here, which we call the critical value, and we will use the t-distribution table to find. So that would be the rejection region for this test. And the last scenario is when we have a two-sided test. So our beta 1 in the H alternative has values to both sides of the hypothesized value. This is versus this null statement. And the rejection region is in both tails of the t-distribution. And let's say the significance level of our test is still 5%. Then the shaded area to the right would be half of that much, and the shaded area to the left, which would be the mirror image of the area to the right, that would be also half of the significance level or the probability of type 1 error. Now I need two critical values, one on the left, one on the right, and these two critical values will indicate the rejection region for us. So any t which is smaller than this negative value here, and any t that is larger than the positive critical value here, would be in the rejection region. Now critical value, those border points, can be found from a statistical table or from a statistical software, which is Gretel for our class. In this video we will look at the table. You have a handout of this table. This table is also at the end of your textbook. And at this point, we know all the information we need to be able to use this table. So first of all, we need to know what type of test we are dealing with. Is it a one-sided test or is it a two-sided test? Level of significance, that's the alpha parameter or the probability of type 1 error. And degrees of freedom, that's n minus k minus 1 for a simple t-test. N is the sample size, k is the number of independent variables that you have in your model, number of x variables that you have in the model, and we deduct 1 as well. So let's imagine that degree of freedom is equal to 13 and alpha is equal to 5%. And for the three tests that we wrote there, we are going to find the critical value. So the first test that we had was a right tail test. That's a one-sided test at alpha of 5%. And the degree of freedom equal to 13. Our critical value would be 1.771. So TC critical value would be 1.771. This was for the right tail hypothesis that we had in the beginning. For the left tail hypothesis, again, it's a one-sided test, so we are still here. The level of significance is also 5%. Degree of freedom is also 5%. Therefore, the number that we find from the table would be again 1.771, but this time it's a negative number because we know that the rejection region is in the left tail, and anything in the left tail is a negative value. So critical value for our left tail test is negative 1.771. For the two-sided test, we have two critical values. So one is the positive, one is the negative. Alpha is 5%, but now I will look at this second row, the two-sided values. So 5% two-sided would be this column. Degree of freedom is still 13. So now the critical value for a two-sided test would be positive 2.16 and negative 2.16. This was for the